Okay, this is a different type of question where we are trying to figure out how much data we need in order to reach a certain level of confidence for our interval estimate. So let's read it. It says, in a study of government financial aid for college students, it becomes necessary to estimate the percentage. So we want to estimate the percentage or the proportion. We're going to estimate the population proportion of full-time college students who earn a bachelor's degree in 4 years or less. Find the sample size. So this is our objective. Find the sample size. So we're looking for n now. Needed to estimate that percentage. We want to use a margin of error of 0.04 and use a confidence level of 90%. So based on allowing a maximum margin of error of 0.04 and a confidence level of 90%, that is going to restrict our interval estimate. In order to reach those parameters, we want an n that is sufficient. So we now have to collect enough information to hit those marks for our interval estimate. So we'll do that using the formulas that are in the reference packet. There's two formulas. One of them is when you have an estimated value to use as your p-hat, and one of them is for when you don't have an estimated value to use for p-hat and then you assume 50%. So A says assume that nothing is known about the percentage that we're trying to estimate. So we're going to go with, let's assume that P is 0.5. And Part B says assume prior studies shown that about 45% of full-time students earn bachelor's degrees. So for Part 2, we're going to let P be 0.45. So the formulas are n equals z alpha half quantity squared times P times Q over E squared. So for this one, it's the 90% confidence has a z-score with alpha equals 0.10, so alpha half is 0.05 on each side. And the z-score I'm looking for, I can find the negative version using inverse, norm.inverse in Excel, or I can look it up in my negative z table. And then I got to be careful to use the positive version so that I can have a positive answer when I get my n. Of course, even if I use the negative in this case, it won't matter because I'm going to square this and then it'll become positive anyways. But just to stick with the convention we've been using when estimating E, we are always talking about the positive version when we're doing stuff for confidence intervals. So if I find using the 0.05 area, I get a z-score of 1.645. Right, so then I'm going to use that 1.645 squared. Then I'm just doing A right now, so then I'm going to use P equals 0.5. Well, if P equals 0.5, then Q equals 0.5 also. So that would be times 0.25, because if I do 0.5 times 0.5, I'll get 0.25. And actually, that's what the formula says. When you don't know, when nothing is known about the percentage that you're trying to estimate, you don't have any prior information to go off of, you just use the 0.25 here instead of P hat, Q hat. And then you will divide by E squared, which is 0.04. Oh, and I want to point out that the formula in the packet is actually P hat, Q hat. So just wanted to make that distinction so you don't get confused when you look at the formula. So we have, this comes out to be about 422.8164063. So we need to have 422.8 people in our study. And since we need at least that many, we're going to have to go one more, because you can't have 0.8 of a person. So the answer here would be 423. And then to do the second part, we will just change this portion of it. So now doing part B, our n is going to be using the estimate of 45%, so 0.45 for p hat and 0.55 for q hat, which will give me a different estimated value. Okay, so that gives me 418.588-ish. So I will need at least 419 people in my study when I know from previous records that about 45% tended to be. Does the added knowledge in Part B have much of an effect on the sample size? Well, it's only 4 people fewer that we need. I mean, we do need less information when we have prior information just as a starting point. So it is less, but I mean, is there really a big difference between 423 and 419? I don't think so. I would say no. Using the additional survey information from Part B does not change the sample size. Or no, using the additional survey information only slightly reduces the sample size. So that's the best answer there, because clearly it changes the sample size, but it's not a lot of a change. So I'm going to go with that.